All right, let's start from a short introduction of the role and what's your interest in AI maybe. Patricia, can you start?
Certainly. My name is Patricia Rennert. I have been with Porsche in different roles since 2005. I'm a mechanical engineer by training. And I have usually been in the production department in rather strategic roles, as also in being the director of a production line in Leipzig for Panamera and the Porsche Macan. However, I was always fascinated by what technology can do, and especially AI as a, well, really a game changer in technologies. And I'm really happy to do that for a living, build software products for company processes. And I enjoy that greatly. And I live here in Berlin with my family. I have a nearly 4-year-old daughter, and she's quite the whirlwind. So in COVID times, that has been quite difficult to manage all of that. And yes, so much about me. And working together with great colleagues is probably the key for Mahdi, because we have been working in the lab together for quite some time now.
All right, so thanks, Patricia, thanks, Alice, and thanks to the rest of the team for having us. My name is Mahdi. I'm heading the software engineering and deep tech chapters at Porsche Digital. I worked in the Porsche context since 2016, building up the lab in Berlin, and now working at Porsche Digital. My background is in software engineering. Started actually with 2 startups in the computer games industry, early 2000s, and then switched to computer science studies, as you could imagine. Most of the time actually worked on software technologies to make software, I would say, easier to handle. So the idea was to basically make programming more accessible to everyone, because it's still up to today a hard task, and we all know that software products and developing them is quite hard. Most of them are behind schedule and so on. You all know that. So yeah, I ended up doing my PhD in self-adaptive systems and modeling, also working internationally in a couple of research labs. And in the end, after some consulting stops in between, as I mentioned, ended up in the Porsche context. I'm really happy to be here. And also will be happy to bring in some software engineering perspectives into the discussion today. And yeah, I guess then it would be me handing over to Markus.
Yeah, thank you very much, Marty. Thank you very much, Patricia and Alice. Thanks for having me here. Happy welcome. My name is Markus Uellendahl, 45 years old. I think I come from the other side, so to speak, from this group, because I'm not coming from the software side. I studied industrial engineering management back in Berlin quite a few time ago. Now I'm in business for 18 years, 9 years for aerospace and 9 years for the Porsche Consulting. As a senior partner, I'm focusing with my team globally on the transformation and enablement of digital products, digital processes within operations. That means more or less on building and supporting the Porsche Smart Factory, the digital production platform as a large project for the Volkswagen Group. As well, in the past 1 year, we did build up the operating and business model for opening up the digital production platform to an open ecosystem called Industrial Cloud, which is coming up this year to the public. So I'm rather coming from the, let's say, client side maybe, and I'm very much fascinated by the possibilities of what the capabilities of AI could bring us. We are really focusing on what could be automated as a process, but more or less focusing on what can we transform in terms of being able to predict errors, predict failures, predict certain scenarios, to use that to optimize and improve our decision making. But we will talk about that later on. So thanks a lot for having me.
Thank you very much, Markus. So we have a very good spectrum from our panelists coming from deep technologies, strategies, industry application, and also from the customer perspective. And I would like to know from all of you, what's your AI vision for the company processes? Patricia, would you like to start?
Of course, I can do that. My vision, I think, as I mentioned in my intro, I think AI is one of the technologies that really is able to change and transform how processes are being well carried out. I think, especially for AI, I not see it as a like overarching changing everything type technology, but more so as a if applied correctly, an enablement for the workers, for the engineers. It can be an even more powerful tool, and in the best sense of the word, can reorganize or re-engineer processes. So to have more robust processes, of course, make them more efficient, and are just one of those game-changing elements that can that processes can benefit from.
Okay, if you want to stick to the order, I can just just jump in here. Same question regarding the AI vision. So to be honest, I thought about this also a bit, and I know that we talked a lot also about AI products and so on, and I'm convinced that it is about the whole product and about having a more comprehensive tech vision than just about what you need for AI. Of course, we highlight it because it's somehow new to us, or it's new to the media again, because if you look like 40 years ago, in the 60s, we already had a hype on machine learning or related. Also before that, more the recommender systems kind of times. And we have always seen this alternation between like these technologies taking off, and then after some time having a phase where people were actually demotivated because the tech didn't meet what was expected. So I believe overall we should have like an overall tech vision. Of course, data is important. Having the right data and not maybe just big data is certainly critical. And I think in terms of the vision, smart algorithms will support us to make better decisions faster, probably. And so decisions can be from strategic levels down to, let's say, decisions made in a factory where you have to see what's the next step for a worker, or what's the ideal time to make a change to a machine, or to call maintenance in. But in the end, I think it's basically about making decisions on all different kinds of abstractions based on data, and hopefully we're able to make them faster than before and have basically better decisions because we are more transparent. And maybe the last point that I like to mention here is that with all this, let's say, magic in the box, we still need to make sure that the decisions or the basis for the decisions are understandable to humans, because in the end, the system will have to work together with our colleagues. And I'm convinced that this is the right way to do it, at least in company processes. So this is definitely an interesting time to work on all of these topics.
Yeah, maybe I can close more or less. The most has been said. I try to frame it a little bit more in a picture. We named it a few years ago. We would like to build the Google Maps of operations, because everyone is used to using Google Maps, or quite able to use it to go from A to B. The system supports you in how much does this trip take you? Is there a traffic jam coming up? What D routes can you use to still reach your target? Maybe even without being able to delay yourself. And that metaphor we used and hope put into AI technology. Anyone having or had the opportunity to work in operations knows how hard it is to take a decision based on data, based on the scenarios you want to reach, and maybe certain parameters have changed. So such an environment and systems who can support you with certain options, you still want to reach your goal, but maybe there's a part missing, or there's a machine failure, or a quality problem, and to overlook that situation, what does that mean for the setup, given any certain options, which is the best to go now, at least in supporting that decision. That would be, to me, a big step change in managing operations as we do it today. So being able to use it as a Google map would be awesome as a vision. And I think AI would be the underlying enabling technology for that.
Thank you, Markus. And I like you come from like different point of view to look at the AI vision, but actually it come all together. So Mahdi, let me change the order. So that's why I like.
All right.
Let me start with Mahdi. So you mentioned AI. We can use AI, the smart algorithm, to help us make the better decision. So, but there are also some constraints or capability of AI. So could you explain us what's the capability of AI and what are the requirements for AI product development?
All right, I will try. I guess we can speak about it in the next hours, and I'm also pretty sure that some of our listeners have great things to contribute. So my take on it would be that basically before machine learning, because I would like to map now AI mostly to machine learning and not to recommender systems or rule-based systems or any other kind of decision making, that this allows us to build basically algorithms given a data set that we don't really have to understand. And we basically also create an algorithm that in detail also the developer doesn't really understand. So basically a really complex problem can be approximated using data and using an approach to create a model that finds its way based on the data. And obviously the limitations come in because you don't really understand what this black box does. So if you look at it if you just picked a neural network, you train it with a data set. And if it's small enough, you can look into it and you can kind of think about what the weights are and what the connections mean. But basically in a real life or industry setting, often I would at least argue that you don't really know what the algorithm is doing. And this may also apply, of course, given sufficient complexity with code. So in the past, if you had, 10 or more thousand lines of code, obviously you could also not just look at it and say it does this and that, but you at least as a developer had the impression that you have the tools to look at it and to understand it. So today I would say, given data, you can create algorithms following a trial and error approach to come to a actually really good solution. And the power in it is that you don't have to exactly specify what you want to do. In the case of matching a cat, obviously it would be a lot harder to describe how a cat looks like. I think just as an idea, instead of letting the machine figure out what the features are that it actually sees in all the pictures that is similar. And yeah, so I see definitely the power of it. I also see the danger, especially if you don't know what the underlying technologies really do. And that's what we see with actually also some applicants or junior data scientists who basically went through a couple of online trainings and then used data that was not meant to be used, let's say, given a certain data distribution or so, with a specific model. So you really should still know the foundations, I would agree. But on the other hand, it's also a powerful way to approach a situation that looks really complex.
Thank you. Yeah, I think like when you talk about the AI is a black box, actually there is a very huge topic now about the explanation ability and the integration ability for AI. And that's like all the scientists are working on it, still very difficult. Yeah, but I think that we now started developing for a while and we see some issues and people are trying to solve it. And talking about the issues and the mistake, Markus has lots of experience in the implementation and also his consulting experience. So Markus, could you share with us what is the most common mistake you see during the AI implementation?
I would answer it from the process and business perspective, since as I introduced myself, I cannot answer it from the technology point of view. But I think the most common mistakes is putting the technology in front of everything without knowing how to realize it and without knowing what to do with it. What do I mean? I think a few years ago, there was a time when we, for instance, printed out that vision about the Google Maps topic I just explained, because everyone was in the hype of believing that AI and this technology, which is just one word, but so much different chapters in that word, will be able to do it. And first of all, I think we had to build up the capabilities within our people and group to handle that technology. That has quite taken some time for us. And second, we had to better understand how we would use that technology in our use cases. I think with us, and what I see most of the time, what fails is if you don't have a certain business goal in the enterprise, from that, which capability you would like to reach, as I just stated, decision support system, for instance, and then you put it out on the different processes, logistics, maintenance, quality. Doesn't matter what type of use cases you would like to implement to reach that goal. And after all of that comes the technology, which is of course also AI as an enabler, being able to implement that certain use case you would like to reach. And I think a few years ago, especially, many people tried to push first the technology, and there are still quite some out there, but that is supposedly to fail. I think how we are moving forward right now is sort of a hybrid mode, let's say, because of course I don't want to be misunderstood that all the people putting effort in understanding that technology, trying to show what is possible and explain what you can do with it, is also a very important part in coming together to understand where you want to go. So you need both, but just pushing it by the way of the capability of the technology, I think is the most biggest failure of the past and still going on.
Yes, I totally agree with that. And I think that coming into Patricia, she has a very interesting experience. So she comes from mechanical engineering background. She was leading the production line from Porsche. So she knows many like companies, processes, issues, but now she is building an AI product at Porsche Digital. So Patricia, can you share with us your experience that how do you find the problem from the company processes? And how do you build up these solutions and also build the trust into it and that the company workers to really accept those solutions?
And I would like to share some thoughts on that. And I think many that Mahdi and Markus have mentioned, I totally agree with in terms of you can't really push something just because it has the label AI, and it's really about the product itself that really has to find or has to give a solution. From my experience, and I really like the saying that my former boss has always mentioned, that problems are in a way treasures, and so we That's how we see problems. And also relying to what Markus has said, we can't really push AI or technology into something. I strongly believe that that is not really possible. It has to come from the problem to be able to find a solution, and that's exactly where we see some changes in the last years, that people have come to us, especially having been given the task of doing research on the applicability of AI and technology to company processes. So we have people from the Porsche AG have come to us and just presented their problems, and I think that's really the beautiful part in this, to be not be given something where it says, okay, find elaborate or build a product on this, but can you solve the solution? Can you solve the problem? Can you find a solution? But how do you do that? I think because you also mentioned my background from the assembly line or from the production area, I do have the aspiration for all of the topics that we tackle, that it has to really solve something and be really usable. And that goes along with what Markus said in terms of it cannot be pushed into something, because that won't work. And I think some of the topics that we need to solve, the user doesn't really care if it's AI or if it's something else, or if it's a different technology that can just really solve the issue at hand. But because you asked, how do we find these problems, or how do we go about that? Well, first, like I said, it's having a problem that you can find a solution for, there where you can also select in a way. But I think the main secret is here to listen carefully, to have a good understanding of the technology and of the problem. And by the problem, I mean, especially that one needs to understand where it originates from. So what is it that the engineer or the worker really tries to solve? So it doesn't really, because I have this example in mind. I forgot who said it, but it was in terms of like, if I would have asked somebody build faster horses and not build a car. And if you look at the example Markus has made, I think some people wouldn't have been able to formulate what it is that really Google Maps is all about. So you do have to understand what technology does and to understand the problem at hand to be able to find a solution like Google Maps or even the car that it solves the user. And then again, what Mahdi said, you have to build a product around it to make it really usable. So if you, to put it in a nutshell, I think it's where people come together and really work hard in understanding each other in terms of what is the problem that we really need to solve, A. And B is what we've seen also from our work experience is that the way data scientists and engineers work is quite similar. It's tinkering. And once you have the understanding of each other, we've seen that it's because when you have trust in the way problems are tackled, you find that you have trust in the solution as well. And we've seen that, well, of course, communication and interdisciplinarity is really the key in achieving a solution that really solves a problem. We have been elaborating and testing technologies really to find the approaches, and then made some interesting findings where we weren't really looking for a solution in this area, but then it solved an even bigger problem that generates a lot of savings. So I think that's really where it comes in. And the last part, the third part, would be creating products, as you've mentioned, that are explainable, and especially for making decisions on the shop floor, it has to be explainable and well, of course, first of all, reliable.
Thank you, Patricia. I really like the example you made, and also the experience you have, and especially coming from like totally like mechanical engineering background, and then now building AI products. So that's kind of the representation of what most of the industry and manufacturer they are trying to do right now to combine the solid engineering knowledge and plus the new technology on top. So I would like to ask all of the speakers here, since you have the experience in different fields, what can you share with us the best practice example for scaling of the solutions? Whoever like to start?
I can start, but I think it's Mahdi's turn, right?
Okay, so thanks everyone. So yeah, let me start then. I think we have to obviously look at what we mean by scaling, and even within this group of participants, and even within our teams, we discussed it a lot in the beginning, because the engineer understands something totally different from the business person when you talk about scaling. But I think in the end, it needs to come together. So from my perspective, if I just pick the tech perspective for the next 20 minutes or so, I would say from the tech scaling perspective, obviously the solution architecture that you build around an AI system is in many ways similar to a more available cloud-based solution, software as a service. In most cases, it will be your choice to use a cloud environment, or if you won't, you will have some sort of a cloud or on-premise cloud or something similar that you will use to host the data, the models, and all of the rest of the implementation. So I think in order to scale it, you must have a different, let's say, you must be able to manage a couple of things. So first of all, maybe if you look at what Patricia said, experimenting with technology to understand if something works, I would place this more in the POC area in the beginning, where you try to understand if you can actually build a solution, if the problem really is a problem, if your solution really is a solution, etc. And from then on, actually, the real work begins, I think, because in many cases, we can actually show that for a limited set of problems with a given data set, we can most likely find a solution. I'm pretty convinced that there is a way to develop that. I mean, of course, there are always different situations, but in most cases that we worked on, we could show that you can have some sort of implementation. But once you want to scale it up and say you have different customers, you want to have it running 24/7, it needs to be secure, it must be integrated into an existing IT ecosystem, and also into existing development processes, then it really starts to become more complex. And for scaling, I think on the engineering side, a couple of steps need to really be automated, because the nature of data science or data scientists is more experimenting with the data and trying to understand or make like reason about it. But when you basically want to engineer the system, you need to follow a more systematic approach. And for example, you will have a continuous integration and delivery pipeline in place in order to be able to react quickly to a change, to something that you need to adjust and quickly deploy and deliver to your customers. You cannot just have a manual step in between and try some parameters with your model and then redeploy it. I mean, this will not be stable. So you will have to think about how you basically merge your data science method and also your delivery processes together with your software engineering processes. And basically, I think most of the people joining in here will also know the ML ops buzzword, but I think it's actually really an industrial problem that we need to look into, and we actually did quite some work in this area. And I'm sure that we will have to build additional tools for lots of the steps that today are still manual when you want to develop systems.
I would enhance it. as Mahdi started first with the definition, what means scaling to me. I mean, if I look at our clients, basically VW internally or outside, they have large production networks. Just for VW Group, that's over 120 plants worldwide. So scaling means if you have a technological solution, a certain use case you can apply in a process step, you want to be able to use that in any process step around the globe in the same aspect, which we find very, very hard, to be honest. Many teams are able to come up with a great solution as a POC or minimum viable product. It's even a product then afterwards in part of a plant, but it's not scalable through the system. So to me, a best practice is one example. A team came up with this used image recognition for a small example, label recognition and documentation, which is not a large thing to do, but that is the, let's say, the application lever which they came up with, but they made available the capability of a data trained model of image recognition to that certain application, and they separated it. So afterwards, other teams could use that capability of image recognition to use it in their own applications. So we had that solution in an assembly, supporting the workers in recognizing and documenting labels if they are correctly placed, correctly used in the different languages of the nations. And other teams use the same technical capability in a different application, for instance, to understand the crack detection in the press shops, or the detection of welding splashes at the paint shop. So we use the same capability throughout our value chain. And that's, to me, a very, very great example of scaling a solution, separating the capability from the application level.
Patricia, do you have anything?
I think many parts of scaling have been touched upon, from scaling from a POC that works into a product, because what you need is data availability, data accuracy, and understanding the data with the view of the engineer. So is it interpretable? I don't know what the word is. And the other is, can you scale it from one process to another? What Markus explained, and I think that's really sometimes dependent on the capabilities, where you can single out a certain approach, or sometimes it is the entire product that can be applied from a body shop shop floor optimization to a paint shop optimization. And then again, that is the part of scaling, where how you apply technology to a certain process. And if you look to various processes that seem at first hand not very related to each other, but then again are quite comparable. We are currently looking at, many of you have been, if you've taken part in AI Monday before, our example of sounds, where we, or AAA as it was formerly called, where we use sound do an anomaly detection on sounds. Of course, that can be also applied to other things, generating frequencies, for example, welding spot performance or welding spot quality. So that may seem totally unrelated. However, that is one example where we can scale one topic to the other. That is scaling not only the capability of the sound recognition or anomaly recognition, but also scaling the product, because the way you build it is, or should build it from my point of view, but there's Mahdi, the pro on this, is being agnostic to a certain use case. And if we build a solution for a certain body shop or a shop floor optimization for a body shop, then we try not to hard code it too much on that specific body shop, but to leave room for it to be applied elsewhere. So I guess the difficulty is scaling. What we mentioned earlier is bringing all of these parts of scaling together. Scaling from a POC to a product, which has certain capabilities, and you have to make the POC work in a product, but then again, think it through so that it can scale to other processes. So that's really sort of getting all of these things together in terms of having it as easy and as fitting to a certain problem as it has to be to scale from a POC to a product. But then again, I think it as big as you should to scale it to other processes and to other plants or factories. So that's really where it makes it even more difficult from a POC to a product.
Thank you very much. So I think we can learn from here that first of all, we need to understand the capability of the technology and also the business issue. Don't just push AI to whatever business issue, but you have different kind of technology solution for that. And once you build such a product from POC, then how do we scale it to run a scalable product and then applying in different use cases? There's a long way to go, but I think we do have the expert here knowing all the knowledge. So this panel comes into the end, and if everyone has any questions, then we will have the breakout session at the end of the session. So you can talk to Mahdi, Patricia, and Markus, all blend directly. Thank you very much. And now we are taking, I think we have time to take one question. So I see that from the chat already, from Khalid. What are the biggest bottleneck you think AI can solve operationally in the automotive industry? This topic is specifically for question is for Markus, but I think all of the panelists do have the knowledge to answer this question. But let's start with Markus.
That's a very tough question. If I would know, I would quit my job tomorrow and start a new. No, try to keep it short. I think, as I mentioned at the very beginning, operations is a network of many processes. Within the processes are people working, machines working, and lots of supplies of parts and tools. That's to name them the biggest four input of such processes. And that's a lot of data and a lot of failure potential, and many parameters can change any minute. And I think if we will be able to build a network of certain solutions connected, that we have the data available of describing these parameters of those processes. If something changes, for instance, there is an error in an assembly causing a quality issue, which we usually, in our case, that means parking the product in some area later on, because it's simply too complicated to arrange within the flow of the products the rework. And that causes a lot of underperformance, a lot of costs and delay, but it's standard as today's industry, even if no one's speaking about it so much. And if we were able to do this still in the flow, although the failure has happened, meaning that means that the part for the rework needs to be rerouted to a different, oh, my video is gone. We can keep talking about AI, but not being able to have the video going on. But if we can be able to reroute, for instance, the parts necessary for the reroute the people necessary to perform the rework, already having identified where this product can be reworked in the Slack of the of the capacity further down the line, but not in the rework area. If we will be able to manage this, set up the system, adapt to that decision, and rework the failure within the line, which sounds small, but that happens every day in each production around the world. That would mean a very good competitive advantage if you are able to manage it like that. And that's just one large example, but it's a large way to go, because it needs lots of data throughout the different processes. And that's why we started building, let's say, small pieces step by step within the sub-processes, and trying to build that vision at the end of the road. To start with small processes working like this, adding it up to the big picture. That's the hope and the mission we try to follow.
I would totally agree. It's micro decisions. I said I would totally agree. It's Mahdi also mentioned it's making decisions based on well, in various occasions, and how that comes together is really probably solving there's no, from my point of view, there is no single bottleneck, but it's very many tiny pieces that overall solve or can improve the performance of production or operations. And that is also the way where we can find different solutions that come into each other, because we see so much data being processed and data being available and overwhelming, so to say, all of the workers and engineer being provided with such data. And what do you do with that? And how do you make decisions based or with too much data? We all know what happens when you have too many emails and too many calendar entries, and you tend to be overwhelmed and not really know what the best decision is. But if you have something that can help you make decisions, that is really the main benefit.
Yeah, maybe I can add one or two more ideas to that. So I think imagining bottlenecks is, I think, what's easiest at the moment, because you kind of can think about improving performance of existing processes. I would also like to broaden the view to maybe new opportunities that you can tackle. So if you think about maybe mass customization or customization of cars just to one user, or basically having customization of user experience for every single user in a way across the whole, for example, car sales or even car experience, even within the car, this would be definitely a way to go. And so, yeah, I think there are definitely many different cases that you can work on, but finding this one case is certainly hard. Yeah.
Okay, thank you very much, Mahdi, Patricia, and also Markus. 30 minutes runs very fast, and I really enjoyed the panel discussion with you. And so now I would like to